Hi everyone, welcome or welcome back to my channel. So in today's video, we are going to solve a question of LeetCode that is based on 2D matrix. So the question says that you are given a 2D matrix which is representing an image, and we have to rotate that image, or you can say we have to rotate that 2D matrix by 90 degree in the clockwise direction. Okay, and one more condition is there that we have to do it in place. It means we're not going to take any extra 2D matrix to perform all those calculations and all, so that obviously the space complexity would be less. Now, first, let's take this first example and think about the approach, how we can think to come on the final code. And here we're not going to learn any formula, learn any code. We are simply going to analyze the input and the output, and then we are going to derive that what formula or what process or what approach we can follow in this. So this is the input which we have been given, and this is the expected output. So basically we have to rotate, what is this? Yeah. So basically we have to rotate this matrix by 90 degree in the clockwise direction. And then we are going to derive this. So when I talk about the clockwise direction, what it means is, now for example, I'm using this peach color. Now suppose this peach color boundary, this should appear here, right? And all the rest of the elements is going to be aligned accordingly. Okay. For example, here you can see the elements are like 7, 4, and 1. I mean, obviously, if I try to read it from downwards to upwards, it's 7, 4, and 1. And after 90 degree rotation in the clockwise direction, it's going to appear here 7, 4, and 1. And then all the elements are going to be aligned accordingly as it was given in the input, right? So let's think that how can we transform from this to this one? Now, we can actually start analyzing it by looking at the transformation in the rows and the columns which are happening over here, right? So what I do mean by saying this is, suppose our 8, right? Our 8 is having row as 2, column as 1 in the input section, okay? And in the output section, our 8 is having row as 1 and column as 0. Okay, we analyzed about 8. Now let's analyze about some different number, let's say 2. So 2 is having row as 0 and column as 1. But in the output part, 2 is having row as 1 but column as 2. So one thing I can clearly see here is that the column of the input, please listen to this part very carefully. The column of the input is going to become the row of the output. One connection which we are getting from, like, by analyzing this input and output thing, right? Am I recording? Yeah. Okay. So the input of, I mean to say, the column of the input is going to become the row of the output. So we can just analyze one thing. We're just trying to notice the transformation. The row of the output is going to become the column of the input. Okay, so this is going to become 3, and we have to see the pattern which column of the output is going to be followed, right? So if I talk about 2, here it's 2, and here the row is 0. Now I can see one formula, like it is following this n minus row of the input minus 1, where n is obviously the size of the column, that is here it is 2, okay, and here the value of r, if I talk about this case, it is 0 and then minus 1, which is going to be 1. So here, as you can see, we are getting the row of 2 as 1. So this is going to follow the formula n minus r minus 1. Okay. So with the help of this equation, which we are clearly able to see from this transformation, we're able to think at least one middle step, that our row is getting transformed into column, and column is getting somehow transformed into row. I'm telling somehow, it means it's not exactly row, but approximately we can say that the row and column are getting transformed into each other. And after hearing this term, we get one thing in our mind, that is the transpose of the matrix. So exactly we are going to uh, take out the transpose of this input matrix, which is going to be the intermediate step, not the final solution. Okay, so then we are going to take out the transpose of this matrix. Okay, so we are going to 1, 2, 3. So here we are exactly transforming the row into column and column into the rows. Sorry for the bad handwriting. Okay, so this is the exactly transpose which we have done over here. But as you can see in this equation, we're not exactly getting r here. We're getting n minus r minus 1. And when we are getting this kind of equation, we can think about one thing, that is reverse. Like generally in reverse, we use this equation, right? And even when we are going to analyze this to this, then we can notice, sorry, from this to the final matrix, then also we can notice that this column, which is 1, 2, and 3, is coming at the last, and this column, that is 7, 8, and 9, I mean 7, 8, and 9, which is here, this second column, it's coming at the 0th index in this. So it means the columns are getting swapped over here. So this is what which we can do. So let's write down its code here. Is the very first step is to take out the transpose, and after that we have to just reverse the columns. Okay. So at first I'm going to initialize the size of the row. Int m is equal to matrix.size, and then I'm going to traverse. So this step which we are doing here, this is basically for the transpose of the matrix. Okay, I plus plus. And then the second loop is going to be, yeah, one more thing, how we are going to take out this transpose of this matrix. Now just notice one thing here. If you're going to notice these diagonal elements now, I'm going to make it a bit clumsy, but it's okay. Okay, so if you're going to notice these diagonal elements and compare it with the transpose which we have derived here, there is no effect on them. They are exactly the same. But if we're going to notice the elements which are on the either side of this diagonal elements, they are getting swapped. Like this 4 was here, this 2 was here, but in the transpose matrix, this 2 is here, but the 4 is here. Similarly, you can see the 7 and 3 are also swapped here. Here 7 was at this point, and here 7 comes here. So from this we can have an idea that how we are going to calculate the transpose in this. So I'm going to run a loop from I to j. Sorry, from 0 to I, because obviously we're not going to go beyond the diagonal because we just have to swap them, right? J less than I, j plus plus, and then we are going to swap matrix of I and j to the matrix of ji. Now, after doing this step, we have already received our transpose matrix. Now we just have to reverse the columns, which we did in this step. Like we got this transpose after writing those code, and after reversing the columns, we'll finally receive our answer. Um, then we'll reverse. Okay, accepted. Let's submit this code. Okay, so it's correct. Talking about its time complexity, we are running here two loops. This is a bit less than big of n square, but still we'll imagine it to be big of n square only because taking the worst case time complexity and it's having a constant space complexity. So this was all about this video. Thank you so much for watching.